Hello class, today we're going to be evaluating expressions like we did yesterday, but this time we're going to be using a T-chart to help us out. Okay, so we're going to look at a different way of organizing our information. So let's look at our standard for today. Our standard this time is a little different from yesterday's, and it says that we're going to represent linear relationships using verbal descriptions, tables, graphs, and equations. Well, one of the things that we have been looking at is we've been looking at translating expressions from a sentence to an algebraic expression. Okay, and that's what that first part of that standard is about. So let's just take a quick look at this. This one first says 5 more than t. Well, the algebra translation to that would be t plus 5, because I have to know what t is before I can figure out what's 5 more than that. Okay, the second one says 6 less than r times 7. Well, the 6 less means that I'm going to subtract 6 from something. Well, what am I subtracting it from? R times 7. Well, one of the things we have to remember that when we're writing multiplication, the number always goes first. So we would write that as 7r minus 6. Okay, the next one says the sum of 4 and w divided by 2. So this sum is one of those big words. It means addition, and it means the answer to an addition problem. So if I know it's plus, this plus is going to go where the and is at. And then the number in front of it will go in front of the plus, and whatever comes after is what goes after the plus. So in this particular case, I know I'm adding. The 4 is going to go in front of it, and it says I'm adding 4 and w divided by 2. So we would write w divided by 2 as a fraction. And then the last one says 9 divided by the difference of 6 and z. So it says I'm taking this 9 and I'm dividing it by the answer to a subtraction problem. So in this particular one, I'm going to have 9, and I want to divide the 9 by the whole thing of the difference of 6 and z. And again, the difference, that minus is going to go where the and goes, which is 6 minus z. So in that standard that we're looking at, that's representing linear relationships using verbal descriptions. Well, today we're going to look at linear relationships in tables, and that's what a T-chart is all about. Okay, tomorrow we'll look at graphs. So let's review what we talked about yesterday. Okay, yesterday we were evaluating a particular expression for some set values. So in this first one it says I want to do 3 times whatever x is plus whatever y is. So now I'm going to underneath that plug in my values. So I'll do 3 times, well, x is 6, so I'll substitute in the 6, plus y is negative 5. And now we just do the math according to order of operations. So 3 times 6 is 18, plus negative 5 gives us 13. Okay, the second one says I want to take 2 times the value of x minus 3 times the value of y, get an answer to that. That's what that big bar says. And then I'm going to divide that by z. So I'll substitute in my values. 2 times 6 minus 3 times negative 5, all divided by 4. Okay, so 2 and 6 make 12. 3 and negative 5 make negative 15. Then we'll take that answer and divide it by 4. So I'm going to change my subtraction to addition next to its opposite. Then I end up with 27 divided by 4, which gives you a value of 6.75. And yes, it is okay to have a decimal value, as long as it's not a repeating decimal. So what we did basically there was I gave you, like on our assignment, I gave you a series of expressions and gave you some static values to evaluate them for. Well, what if I gave you, or I give you multiple values for only one expression? Okay, so take for example this one right here. The expression is 2x plus 3. And I say evaluate it for all of these values right here. Well, what you would do then is you would take your 2x plus 3 and you'd substitute in a 0 the first time, and then we would do the math. 2 times 0 is 0, plus 3 is 3. And then I would do it again. 2x plus 3, plug in our 3, so 2 times 3 plus 3. So that would give me 6 plus 3, which would give me 9. And I would have to do that for every one of those values. Wow, that would be a lot of work. Okay, so wouldn't it be nice if we had a way to organize all of this information so that it would be a little bit easier to do? And believe it or not, we do. It's called a T-chart. So let's look at that same exact problem, but this time let's organize our information in a T-chart. Well, this T-chart, believe it or not, it speaks to me. And what it says is, if x is negative 2, then 2x plus 3 is what? Okay? So this T-chart really asks us a series of questions, and all we have to do is answer those questions. So this first time, our x value is negative 2. So we would do exactly like we just got through doing. We would take our expression, and I would substitute in my x value. So I would do 2 times negative 2, which is negative 4, plus 3, and get negative 1 as an answer. Now my x value changes. So now it says if x is negative 1, then 2x plus 3 is what? Okay, so we do it again. 2 times negative 1 plus 3. Well, 2 times negative 1 gives me negative 2, plus 3 gives me a positive 1. Now, let's look at one more real quick. So now if x is 0, because now my x value changes, then 2x plus 3 is what? So 2 times 0 plus 3. Well, 2 times 0 is 0, plus 3 gives us 3. Now, if when we organize this in a certain way in this T-chart, instead of having to show the work every single time like we were doing on this problem, we can actually begin to look at patterns. Because algebra is nothing but the study of patterns. So if I were to look at my pattern as I'm going, I'll notice that I'm increasing by 2 each time. So if I'm increasing by 2 there, then I could look at the pattern to find the rest of these. So if I increase by 2, I get 5, and then 7, and then 9. So the advantage of this T-chart is I don't have to do as much work, and I can begin to see patterns. Okay, so let's try another one real quick. Okay, so this one right here, we've got one that's a little bit different. Now, one of the things that I would do on this particular one, because I see in that expression it's 3 times the x value, or whatever the value of the x is, minus 2. Well, I don't like minus. So I'm going to change that minus to a plus and the next number to its opposite. And that's going to prevent me from making some careless mistakes. So now my first x value is negative 2, so I'm going to substitute it in for x. So 3 times negative 2 plus negative 2 would give me, 3 times negative 2 gives me negative 6, plus negative 2 gives me a negative 8. Then I change my x value to negative 1. So 3 times negative 1 plus negative 2. Well, 3 times negative 1 is negative 3, plus negative 2 gives me negative 5. And then I do one more with a 0. 3 times 0 plus negative 2. Well, 3 times 0 is 0, plus negative 2 gives me negative 2. Now, once you have evaluated it for 3 x values, you now can determine a pattern, because it does take 3 answers in order to determine a pattern. So here, you'll notice I'm increasing by 3, increasing by 3. So that means to go to the next one, I'm going to increase by 3 to get 1 and 4, just like that. Okay, so let's see if you can do one on your own. Pause the video and answer this one on your own. Okay, let's see how you did. Well, this one says negative 2 times the value of x plus 6. Okay, so I come over here, negative 2 times my first x value of negative 2 plus 6. So negative 2 and negative 2 make positive 4. Plus 6 gives me 10. Okay, then I go to the next one. Negative 2 times negative 1 plus 6 gives me 2 plus 6, which gives me 8. Okay, and then negative 2 times 0 plus 6. That gives me 0 plus 6, which is 6. So what you find out here, our pattern is not increasing this time, but decreasing. We're decreasing by 2. So that means I'll decrease by 2 more and get 4, and then 2 more to get 2. So hopefully those were the values that you came up with. So you find out that to evaluate a T-chart is the same exact thing as what we were doing with an expression. It's just this time I keep only one expression and I evaluate it for multiple x values. Tomorrow, we find out what this T-chart is for and what it's all about. So until then,